99% of life on Earth vanished. This was the cost.
Life on Earth vanished. This was the cost.
This wasn't a single mountain, but a planetary wound. We focus on the Siberian Traps, an eruption of unimaginable scale. The process begins deep within the mantle, not typical volcanoes. A heat and pressure cause the rock to liquefy into superheated magma. This magma rose slowly, collecting in vast chambers below the crust. But the crust above was weak, fractured by tectonic stress over time. And now that we understand the source, let's explore the eruption mechanics. This was not a steep cone, but massive flood basalt eruptions. Millions of cubic kilometers of magma poured out over epochs. These flows solidified into the distinctive, layered rock formations we see today. The resulting provinces dwarf any single volcano known in human history. Crucially, the magma interacted with existing carbon-rich sediments. This contact metamorphism released vast quantities of greenhouse gases. Sulfur dioxide, methane, and carbon dioxide choked the young atmosphere. This initiated the planet's most severe climate change event. The greenhouse effect rapidly spiked global average temperatures. The warmer surface water prevented vital oxygen from sinking into the deep ocean. This created massive oceanic anoxic events, literally suffocating marine life. On land, acid rain began dissolving exposed rock and vegetation. The plants, the base of the terrestrial food chain, began massive die-offs. The sheer volume of gas overwhelmed the planet's natural buffering capacity. And the eruptions were not instantaneous, they spanned perhaps 1 million years. Geologists read this history locked within ancient rock strata. The boundary layer shows the immediate, catastrophic loss of biodiversity. But over 90% of marine species could not adapt to the new chemistry. But the massive heat also altered groundwater systems and regional hydrodynamics. Even after the eruptions waned, the climate effects persisted for millennia. The life that remained faced sustained stress from the changed environment. Recovery required immense geological timescales, fundamentally resetting ecosystems. With the resulting atmospheric imbalance favored small, generalized organisms. Today, the scale of the Siberian Traps remains a geological benchmark. Life is tenacious, finding purchase even on the hardest, most recent rock. And now that we understand natural catastrophe, let's contrast with modern inputs. The key difference lies in the rate of gas injection into the atmosphere. Supervolcanic events trigger runaway positive feedback loops naturally. The mechanism depends on deep crustal structures and prolonged magmatic plumbing. Rivers and deltas of that era received enormous sediment loads from erosion. A chemical fingerprinting confirms the unique signature of these mantle plume eruptions. Imagine an event where the entire North American continent flooded with lava. Or for the creatures living then, the sky itself was an enemy. The process eventually exhausted the immediate magma supply beneath the crustal weak points. It took millions of years for natural carbon sinks to rebalance the climate. The geological record preserves evidence of the lingering ocean acidification. Understanding the mechanism shows how slow processes become sudden global disasters. Only the most adaptable lineages survive to populate the recovering Earth. The Siberian Traps represent the ultimate geological forcing event. But these colossal eruptions fundamentally reset the evolutionary trajectory of our planet. The energy released reshaped atmosphere, oceans, and the very surface. Our protagonist, the geologist, now understands the deep time context. It took a pause, but the biosphere eventually found a new equilibrium. This process teaches that planetary stability is a dynamic, ongoing negotiation. But the scars of the Siberian Traps remain visible from orbit, geological ghosts. And the ocean acidity spike was the most lethal, long-lasting consequence. The key takeaway is the amplification factor of subsurface heat sources. A slow geological trigger can result in an incredibly fast ecological collapse. Low wind patterns were completely rerouted by sustained thermal gradients. We are studying ancient cataclysm to understand planetary resilience limits. It is a humbling reminder of nature's capacity for both destruction and renewal. The story of the supervolcano is the story of Earth's ultimate reset button.